got home from something.
That's okay, no problem.
Late.
I'm going to be a little restricted on how late we can go over because I have a 6 o'clock session that I'm going to have to get to.
Okay.
We'll do what we can do. You have some stuff you can verbalize for me, or?
Not right off the bat, but we are working on quadratic equations right now. I don't really know how to do those.
Okay. Well, there's lots of things that quadratics involve. You graphing them, factoring them, solving them, putting them in vertex format.
Graphing them and solving them mostly, I think.
All right. Let me make up a few. If you wanted to solve that, how do you do it?
This is our squared minus.
In other words, that's a standard quadratic.
Okay.
If we can factor this so that we have two things multiplied together equaling 0, then we can solve it. Okay? If I tell you that A times B equals 5, you can't solve for either A or B. But if I tell you A times B equals 0, well, the only way that can be true is if A is 0 or B is 0. So if I've got the product of some number of things being equal to 0, then it allows me to solve it. So the goal here is to split this up, basically the opposite of FOIL. FOIL is where you multiply a binomial times a binomial. Well, this is where you take the quadratic that would result and split it up into the two linear factors. So how do we do this process? Let's talk about it. If you don't know how to do this, we definitely need to talk about this.
Okay.
A simple one like this, and I classify it as simple because the coefficient of the x squared term is 1. So whenever you have a problem like this, there's really 3 real simple steps, maybe 4, that you do to factor. And it might be worth writing these down. Step 1, split up the x squared. When I multiply it back together again, x times x is going to give me x squared. So I've split it up. Second step, determine your signs, both of them. What are my signs going to be? Is it going to be plus, minus, plus, minus? What is it?
Probably minus, I think.
Well, if I add minus, minus, this would have to be a plus. Or if I had plus, plus, that would have to be a plus. So I look on the sign of the constant, and that tells me my signs have to be opposite. One has to be plus, and the other has to be minus. I know that much. So that's step 2, to determine what both signs are. Step 3, looking for factors of the number, the constant, that subtract, because of that negative sign right there, to the coefficient in front of the x term. In this case, 1. So what factors of 6 subtract to the number 1? Listing all of the factors of 6 over on the right.
Okay.
Which 2 subtract to the number 1?
1 and 2 and
Well,
2 and 3.
This one here only. These 2 subtract to the number 5.
Oh, okay.
Okay? So I don't want that set. So I want the 3 and the 2. Now, to figure out which one goes where, I put the biggest factor, the 3, with the sign of the middle term. The middle term sign is negative, so that's where my 3 goes. My 2 goes there. Okay. So, if I want to check and see whether or not I did it right, I don't really have to completely FOIL this thing back together again. First of all, I know I did that right, and I know I did that right. 2 times minus 3 gives you that minus 6. X times x gives you the x squared. So the only term I really need to check is the middle term. How do you get the middle term of a quadratic? It's from the O and the I of FOIL, from the inside and the outside terms. Well, the inside terms are plus 2x when I multiply them together. The outside terms are minus 3x when I multiply them together. Add those two together, minus x, that's my middle term. I've done it properly.
Okay.
Now, there's one last thing that still is required to solve this equation. Remember, I'm trying to solve for x. And it's all I know for sure is that either that has to be 0 or that has to be 0. So my very last step is to set both of them equal to 0. I'm going to set x plus 2 equals 0. I'm going to set x minus 3 equals 0. I'm going to solve each one. X minus 2 is one solution. X equals 3 is another solution. Okay? Let's take another simple one. Simple only because the coefficient is 1. In other words, this would not be, I wouldn't call that a simple one, and I'll get to that in a moment. But there's a certain set of rules for simple ones, and then there's another set of rules on how you factor a little more difficult ones. Let's take this one. First step.
So you put x in both of them. Just put the x squared.
Second step.
Would you find out what sign you were going to have in there?
Okay.
Or
yep. What are my signs, both of them, going to be?
They're both pluses.
Right. Now what? Now I want factors of 6 that do what? Not subtract to the number 5, but add because of that.
Okay.
Yeah, and it's 3 and 2. Because 3 and 2 are factors of 6, and they add to the number 5.
Okay.
Those 4 steps are all you ever have to do for a simple quadratic.
I'm sorry about all the background sounds that just came in.
No problem. Let's try a little tougher one.
You want me to adjust them a little bit taller?
Think a moment.
Okay.
You all right?
Yeah. Sorry.
All right. This would be level 2 degree of difficulty. What's the first step?
So you would want to split up the x.
I want to split up the whole thing.
So would you have x squared in each set of parentheses?
No, you never split. You never have x squared. You're going to have 2x and x. Like, the only thing you have to make sure is that when you multiply these two numbers together, they give you this. And 2x times x does give you 2x squared.
Okay.
And this is never a solution. You never do this. Even though 2x squared times 1 does equal 2x squared, you do split up the x's always. Okay? What's the next step?
To find out what the signs are.
What are they going to be here?
Is it going to be a plus sign and a minus sign?
Yeah, only here it's different. In other words, that plus minus is not necessarily going to be the same as this plus minus plus. So I'm going to allow for both of them. I'm going to put both the plus minus and the minus plus. It's either one or the other, but we don't know what yet at this time. When we had a simple quadratic, we didn't need to do that because it didn't matter. Plus minus was the same as minus plus. But with a slightly more complicated quadratic, we do need to allow for both. All right, now all we're dealing with is factors of 3. Well, there's not a lot of choice. 3 and 1 is our only choices. And at this point, it becomes kind of trial and error. Okay? Let's try 3 there and 1 there. I know that this first term's correct, and I know this term is correct. So the only question is, what middle term does this give us? What's this?
So it's 1x.
What's the outside?
That is 6x.
Minus 6.
Minus
The sign is as important as the number. If you get the sign wrong, you're going to get the problem wrong. Okay? Add those two together, you get minus 5x. That's not our middle term. That's not the correct way to do it. So, let's swap them. Let's put a 3 there and a 1 over here. Does that produce the correct middle term? Goes here?
So you have 3x.
Yeah, and just for the sake of argument, let's show the plus sign, even though I understand that it's assumed if you leave it out. But in this case, we really want to check to make sure we get exactly plus x. So let's put our plus sign in there. It'll help us. What goes down here?
Minus 2x, right?
Add them together. What do you get?
Just x. Or 1x.
Plus x. And that's exactly what our middle term is. That means we did it correctly. So I can erase all of this. I can erase that minus plus, and there's my answer. Almost. There's my factoring. Now what's going to be the solution? How do I solve for x? Either that has to be 0 or that has to be 0.
Right.
So let's start by stating that. 2x plus 3 has to be 0, or x minus 1 has to be 0. Solve the first equation.
So 2x would be
Right?
Yeah.
Now,
So x would equal 1.5, right? Or negative 1.5?
let's just leave it as an improper fraction like that. Okay. And in the bottom one, if x minus 1 equals 0, what's x equal?
1.
Okay. So there's your two answers. Now typically quadratics always have two answers. They don't always have to have two different answers. Sometimes they can have the same answer twice. But technically they always have two answers. In other words, if I had this quadratic, that's going to factor into x minus 2 times x minus 2. So I only get one answer, but I get it twice. In other words, both answers give me the same thing. If x minus 2 equals 0, then x equals 2. It doesn't matter which one of those I use, I only get that one answer. So you don't always get two different answers with a quadratic, but if you're only getting one answer, you haven't done enough. You need to find your second answer, make sure that it's included in your answers. Now, let's look at that previous one just a second here again. What was it, minus 3? Yeah.
I think so, yeah.
And I separated it 2x, x. I know the signs are different, but I can't live with just that because it may be a minus over here and a plus over here. Now let's say that my first guess was 3 here and 1 there. Now notice when I check for my inside term, I get minus x. So I get the right coefficient but the wrong sign. When you get that, all you have to do is move the same number up to the opposite sign and it will produce the plus x in the middle. So that's helpful. In other words, we only have two factors to try and there's only 4 possibilities. It's either 3 and 1, 1 and 3, 3 and 1, or 1 and 3. Well, the moment we try the first one, it eliminates one of the others. In other words, when I first accidentally tried that, it gave me minus 5x in the middle, which isn't even the right number, which means there's no way, in other words, if this produces a minus 5x in the middle, then if I move the 1 down there and the 3 over here, all it's going to do is give me a plus 5x in the middle. I can eliminate that solution. So I don't have to try moving these down. Next step is to swap them. And when I swap them, I get my answer. So it's not like you always have to try all 4 solutions. With your first solution that you try, you eliminate 2 of the solutions. So I really only have to try 2 solutions. So there's not a lot of trial and error, but there's a little bit. And no matter what method they've taught you, even if they teach you something called the California method or the diamond method or something like that, there's trial and error in it. So my method, I don't call it the California method or the diamond method. I just do it the way I've described it to you, and it works really well. In other words, if you follow these rules. Now, notice I have this second degree of difficulty, not because it's a 2, but because it's not a 1. I have that degree of difficulty. I no longer can make any of those statements that factors of 3 that add or subtract to the number 1. You got to throw that out the window. In other words, you can apply the first 2 steps, but once you get to this point, Now you have to say factors of 3 that I'm going to try randomly until I produce a middle term of plus x.
Okay.
There is nothing else you can say. I can't say factors of 3 that add to 1 or factors of 3 that subtract to 1. You can no longer do it. Even if this were a 2x over here. In other words, if that's 2x, in other words, let's say we started with 4x squared, and I separated into 2x and 2x, well, I still can't say factors of 3 that add or subtract to the number 1. The moment it's something other than x and x, you got to throw that last rule out the window and just start trying different factors. So if you have a problem like this, they're not going to give you a problem like this because there are so many different factors of both this number and this number that you'd be there all day trying them until you produce that middle term. So they're not going to give you problems like that. When they give you the second degree of difficulty problems, there won't be that many factors. This is about as tough as you'd ever see, where you've got a couple of different ways you can factor that, and you got a couple of different ways you can factor that. It doesn't have to be factorable. You can easily have a problem that's not factorable. Change that to a 5 instead of a 3. That's probably not factorable. I can't find 2 linear factors that result in this. And when you get that situation, you bring in the quadratic formula. That's when you resort to x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. So when you find a quadratic that you cannot factor, this is what you use. And remember, a is this coefficient only, b is this coefficient, in this case b is plus 1, c is minus 5. You don't bring along the x, it's just the coefficients that represent a, b, and c. Okay? All right, well, that's about all we can do, I guess, for tonight.
All right.
But that should be, if you haven't mastered what we've covered tonight, you want to review this thing. You'll get a copy of it by tomorrow. Make sure you know how to do everything we've done in this session. Because if there's one thing you absolutely have to know, it's what we covered tonight.
All right.
All right?
Sounds
okay, Matthew. I'll talk to you next time.
All right. Thank you.